Welcome to AI News Digest 2026-0613. Today's 8 stories. Story 1, Globalization is dead, Sridhar Vembu says after U.S. restricts Mythos and Fable access to Americans only. Story 2, GPT-5 launching between July-September 2025 won't launch unless it clears strict internal benchmarks. Story 3, is this AI's moment of truth? BBC News. Story 4, an exploratory study of large language models in preoperative anesthesia assessment. Story 5, comparative evaluation of multimodal large language models for Mayo Clinic use cases. Story 6, real-time educational personalization using fine-tuned large language models. Story 7, epistemic stress tests on closed LLMs, neuropsychological perspective. Story 8, why decade-old residual connections still power all of AI and why it's a problem. Story 1, Globalization is dead, Sridhar Vembu says after U.S. restricts Mythos and Fable access to Americans only. A researcher named Elena Marziali has published findings from what she calls epistemic stress tests on 6 major closed AI language models: Grok, ChatGPT, Copilot, Claude, Gemini, and a system called Muse Spark. The work appears on Hugging Face's research forums and is backed by a formal repository on Zenodo, making it reproducible in principle. Here is the core problem she set out to investigate. When a language model produces a fluent, well-structured, formally correct piece of text, does that mean the claims inside it are actually verifiable? The answer across every model she tested was no. Every single one produced what she calls epistemic failures, unverifiable claims, unsupported inferences, and untraceable assumptions, even when the output looked polished and credible on the surface. Because these are closed, proprietary models, she could not inspect internal weights or activations. So she adopted a neuropsychological approach. When you cannot open the system, you study its behavior. She gave each model a complex academic task, then had an external validator check every factual claim against traceable sources. The model-by-model breakdown is striking. Grok produced many epistemic failures despite formal correctness. ChatGPT showed rhetorical coherence combined with what she calls pseudo-formal confabulation, meaning it sounds authoritative but isn't grounded. Copilot was mixed. Claude ranked highest for verifiability, but she argues this comes from paraphrasing strategies, not genuine self-awareness about what it knows. Gemini produced technically correct content, but offered no explicit justification or traceable references. And Muse Spark generated domain-specific confabulation. From these findings, Marziali formalizes what she terms the epistemic boundary, a persistent uncertainty regime that does not depend on how you phrase the prompt, what retrieval system you attach, or how good your external checker is. It is, she argues, baked into the way these models generate text. A related post by the same researcher cites a persistent 8 to 15% failure rate across domains as quantitative evidence for this boundary. The implications are serious. If this finding holds up under rigorous replication, it means that organizations using closed LLMs for research, legal analysis, or medical information cannot rely on fluency or formal structure as proxies for accuracy. External verification pipelines are not optional. They are essential. And more fundamentally, it raises the question of whether better prompting or retrieval-augmented generation can ever fully close this gap, or whether the architecture itself needs to change. This work has not yet undergone peer review, and the sample sizes are not disclosed, so it should be treated as a compelling hypothesis rather than settled science. But as a behavioral stress test of systems that billions of people interact with daily, it deserves serious attention. Story 2, GPT-5 launching between July-September 2025 won't launch unless it clears strict internal benchmarks. Here is a question worth sitting with. While the artificial intelligence field has transformed almost beyond recognition over the past decade, from convolutional networks to transformers, from models with millions of parameters to those with hundreds of billions, one foundational design choice has remained essentially unchanged since 2015. That design choice is the residual connection, and a new article in Towards Data Science, along with a research paper from DeepSeek AI, argues that this decade-old idea may now be holding the entire field back. Residual connections were introduced in 2015 by he and colleagues as part of the ResNet architecture. The concept is elegant and simple. The output of any neural network layer is the sum of what that layer computes plus what it received as input. That bare pass-through of the original input, called the identity mapping, solves a critical problem. It creates an uninterrupted highway for gradient signals to flow backward through hundreds of layers during training, preventing the vanishing gradient problem that made deep networks nearly impossible to train before. The issue is what happens at scale. In a standard transformer model, the residual stream has a fixed width. A single vector of dimension sees every piece of context, every memory, every feature representation the model develops across all its layers has to be crammed into that same fixed-width channel. As models grow from hundreds of millions to hundreds of billions of parameters, this becomes a severe bottleneck. You are widening the highway, but keeping all traffic funneled through a single interchange. DeepSeek AI has now published a paper proposing a replacement called manifold-constrained hyperconnections, or MHC. The approach redesigns how information routes between layers, potentially allowing different types of representations to travel through more specialized pathways rather than being compressed into a shared stream. The manifold-constrained framing suggests the routing respects the geometric structure of the representation space, which could reduce the information loss that accumulates as signals pass through dozens of layers. If this works at scale, the implications are substantial. Every major commercial language model, GPT-4, Claude, Gemini, Llama, is built on the residual connection paradigm. A validated replacement that routes information more efficiently could reduce compute requirements, enable deeper networks without adding proportional parameters, or unlock capabilities that current architectures suppress. DeepSeek's willingness to challenge this decade-old primitive signals something important about their research strategy. They are betting on architectural innovation, not just scaling, as the path forward. Whether MHC delivers on that promise remains to be seen, but the question it raises deserves serious attention from anyone building the next generation of AI systems. Story 3 is this AI's moment of truth, BBC News. A conference paper published through IEEE in 2026 takes on one of the most persistent challenges in modern education. How do you deliver truly personalized learning at scale, in real time, for every individual student? The answer proposed by the researchers is a system that combines fine-tuned large language models with continuous learner behavior analytics, creating a pipeline that can dynamically adapt educational content based on how a student is actually engaging with the material moment to moment. This is a meaningful departure from how most adaptive learning platforms work today. Traditional systems follow pre-programmed branching logic. If a student gets 3 questions wrong in a row, bump them back to an easier module. The approach described here is more fluid and generative. Instead of navigating a fixed decision tree, the LLM can generate or select content on the fly, responding to nuanced behavioral signals like reading pace, error patterns, and engagement time. The decision to fine-tune the LLM rather than use a general-purpose model off the shelf is technically significant. Fine-tuning allows the model to learn the specific vocabulary, difficulty gradients, and pedagogical patterns of a given educational domain. A general model might know a great deal about mathematics, but a fine-tuned educational model understands how to explain calculus to a struggling high school student versus a confident one. The implications for education are substantial. Adaptive AI tutors that respond in real time could help close learning gaps that traditional classroom instruction cannot address, particularly for students in under-resourced settings where individualized teacher attention is limited. Corporate training and professional certification programs could also benefit, delivering relevant content faster and reducing time wasted on material learners already know. That said, real-time behavior analytics means continuous monitoring of student activity, which raises serious questions about data privacy, especially for minors. As educational AI becomes more capable, institutions will need to balance personalization benefits against the responsibility to protect learner data. Story 4. An exploratory study of large language models in preoperative anesthesia assessment. This peer-reviewed study investigates the practical application of LLMs in perioperative anesthesia assessment, a high-stakes clinical domain. Researchers explore how LLMs can assist clinicians in preoperative evaluations, highlighting both capabilities and limitations. The work contributes to the growing body of evidence on LLMs in specialized medical settings. Story 5. Comparative evaluation of multimodal large language models for Mayo Clinic use cases. This study systematically compares multiple multimodal LLMs on medical tasks relevant to gastroenterology, using the Mayo Clinic as a benchmark context. Conducted in late 2025, it provides rigorous head-to-head benchmark results for leading models in a clinical setting. The findings offer actionable guidance for healthcare institutions evaluating LLM adoption. Story 6. Real-time educational personalization using fine-tuned large language models. Published on IEEE Explore, this research presents a system combining fine-tuned LLMs with dynamic learner behavior tracking to enable real-time personalized education. The approach adapts instructional content on the fly based on student interactions, demonstrating a practical LLM application. It represents a significant step towards scalable AI-driven adaptive learning. Story 7. Epistemic stress tests on closed LLMs, Neuropsychological perspective. This Hugging Face discussion thread explores safety and alignment research by applying neuropsychologically inspired, epistemic stress tests to closed-source LLMs. It examines how models handle uncertainty, contradiction, and knowledge boundaries, topics directly relevant to AI safety. The thread references related work on paraconsistent logic and epistemic policy transfer in LLMs. Story 8. Why decade-old residual connections still power all of AI, and why it's a problem. This technical article examines how residual connections, invented over a decade ago, remain foundational to modern transformer-based LLMs despite architectural evolution. The author argues this dependence may represent a structural limitation holding back further AI progress. It offers a substantive, research-grounded perspective on AI architecture challenges.